Okay, this is the bridge in action. It's one of the first trains going across the bridge. There's the train coming out on this side of the wall. Stop it there. Okay, the bridge just pops through the wall at this point and comes out on this side. Now we'll have a little look at how the bridge operates. So by lowering or pulling the slide on this side, it releases it and lowers down. And you can see the soft action it has, and that's from the shock that's in there. I use a 40-pound Suspa shock, I think, which I've showed already. It's connected here. On the other side, it's connected to a stud in the wall. I'll show that a little later on. Okay, here's a shot of some of the hardware that's going to be used on the bridge. First of all, this is going to be the part that's attached to the bottom of the bridge. Okay, so this is going to swing down like this as the bridge is lowered. See, I just have a bolt attached through this point here, and then the end of the shock is going to be attached to that bolt. This is the shock itself. It's the same kind of shock you'd find on your on a hatchback, or maybe in the trunk of some cars. This is manufactured by Suspa of Grand Rapids, Michigan. It can be purchased on their website. Now I'm going to be trying a 40-pound shock here, and you can see on the end of it I have a little loop. Now this is just screwed on to the end of the shock. It comes with different, or you can purchase different attachments for the shock. You can also have an end like this if you have a straight pin for it to go on, or something that's like bearings. And then this one, if you have a ball that's going on the other end, you could attach, a ball like this to your hinge point. Unfortunately, it doesn't have the right configuration. I need something in this orientation, and this plate wasn't going to work, so that's why I put the pin on this. This is another Suspa shock that I had. This one's only 30-pound rating, so it's not quite as strong as this one, the 40-pound that I'm going to try and install first. Now, this plate that I have here, that's what I have mounted inside in the interior of the base. This is you can see the base of the bridge there, the hinge point. Okay, I got a set of hinges right there, and that plate is mounted back probably about 14 inches, I believe, is the dimension from the hinges. So let's look a little bit at the backside of the wall. Now this doesn't have to be hidden at all. This could be underneath your benchwork or whatever. But up here we have the track running across. Okay, you can see it running across there. That's the top of the benchwork. This is the base of the shock underneath. It's anchored here at this point on a ball. That's a piece of mounting hardware that comes with, that you can get with the shock. And so that's one of the critical points there. And then this is a pressure switch, or an on-off trip switch. That cuts the power. The green and the red wires are the track power. So this is going to cut the power to the last 3 feet of the green track wire. And let's see how it moves. this is in the bridge up position, and the bridge is moving, or sorry, that was in the bridge down position. I just moved the bridge up, and the shock actually drops when the bridge goes up because of the mounting point at the other end. It swings down, and that brings the shock down and releases the pressure switch, so the track power is restored. I'll do it again. So now I'm putting the bridge down, and the shock moves up. As the bridge moves down, throws the switch, and that's it there. So this point is very critical, and we'll look at that on a diagram. As mentioned, here's the shock. It goes inside. See that silver plate there? That's got a little bolt on it. It's kind of like a knob shape, and it anchors on the other side. So when it goes down, the shock actually raises up a little bit. This hinge point is very key. The location of this hinge point and this hinge and your mounting location. I'll describe that on a little diagram in a minute. On this end, you can see the tracks are attached to PC board ties. I anchored those down first, and I made sure they were at the exact same height as the rail, and then mounted the track across it, soldered the rail to it, and then cut through the rail. And you can see it leaves a little gap there, which is perfect. It's almost like a mechanical stop. I do have an electrical stop, but I do plan to run Stay Alive decoders, and if one were to come off the end, it's going to fall in that little ditch and not go over the edge. So the last 3 feet of the track have a switch, so when this is open, it cuts the power to the track 3 feet on either side. So that's this side. Now this is 3/4 inch marine grade plywood, and I use some aluminum. One side has an aluminum L bracket, this one has just a straight aluminum piece. Could have put an L bracket on this side too, and I just screwed it into the plywood along the side to stiffen it up. And I put a clear, some plexi on the side, just in case, so the trains can't roll off. And I've just used a manual throw for this switch on the bridge. And here's another close-up of the end. And then over on this side, same thing. I got 3/4 inch plywood, some cork road bed that I had to use just to bring the level of the plywood up, so that when the bridge is closed, they meet up perfectly. Now before I close the bridge, see I have, this is a block of what's called UHMW. I happen to have a block sitting around. It's very slick. Nothing will stick to it. So it's very good for the bolt to slide in and out of there and not get caught. And then underneath I have this aluminum plate. It's got a little bit of a draft angle on it, but it captures a plate on the other side, so it pulls it in and also centers it, so within a couple thou of an inch. And then this is my automatic shut off on this side, so this cuts the power to the tracks. So when the bridge is closed, that's going to go up and restore the power to the tracks. When the bridge is down, it cuts the power. So those are 3 key things. You want to align it properly, both directions. You want to be able to lock it closed, and you want these ties to line up, or the rails to line up every time when you close it. So now I'm going to close it. Now you'll see with the shock, there is acts sort of as an assist. And basically, I don't even have to push it, or I just give it a little push and it goes up, you know, almost all the way. Let's put it in place. Sorry, it's tough to do this in one hand. Put that in place, lock it in. You see the rails are lined up quite good there. So the key is to get these level and match the height of your ties. And then I cut out the cork road bed underneath and brought the ties right over top of brought the rails right over top of the PC ties, soldered them down, and then cut them through the middle. And then you got to make sure, of course, to gap these to stop the shorting action. And then back here, about 3 feet from the bridge, I've cut a little gap in the tie, and this power goes through that cutoff switch, the power to that rail. So now on the bridge, you can see the mating plate that goes into the other aluminum plate. You can see it's got a little bit of an angle on it as well. So it's very reliable. Lines up. Now the other beauty of this shock, when I lower this down, you know, I can lower it down with basically one finger and it's not going to drop. And then I have a stop. Once it reaches a certain point, the shock takes over and it will hold it closed. Because now, sorry, just can't do that with the camera here. But it's going to hold it closed because the shock is now past the line where the hinge is, and it starts pushing the cam upwards. Let's look at that on a little model that I've created here. Okay, so imagine this is the bridge here. This is the bridge, and there's 3 key points. This is the hinge for the bridge at the top. This is the one mounting point for the shock, and this is the other mounting point for the shock. It's back in behind. Okay, so right now the shock is running like this on this angle here between those 2 mounting points. As this closes and hinges, as you drop the bridge, okay, you'll see that this mounting point here, the shock is compressing and the angle is starting to get closer. There's a triangle here and it's getting flatter and flatter. And as this point, as the triangle flattens right out and that point gets past perfectly flat, then now this is starting to push on this angle, okay, and it wants to basically hold the bridge down because now it's past this straight line between that hinge and that mounting point, and this mounting point is now above that flat line. And at that point, it wants to start pushing the bridge this way ever further because this wants to expand again. So it's really key where you have this mounting point and this mounting point here. See, as the bridge opens up a little bit, it reaches a certain point, and then all of a sudden the shock takes over and it's going to push the bridge up as the shock expands. Now the rating of the shock will tell you how much weight that shock wants to lift and how hard it's going to push on the bridge. So I got it just about right with the 40-pound shock. If it was 30 pounds, this bridge would just kind of sag at about there and not go much further. And you're going to push it. And the other rating that you have to look at is how far of a throw this shock has. So how much of a piston throw. So you see that it compresses. As it closes, the shock is going to compress. So that's going to be your minimum distance, and this is going to be your maximum distance. And that's all on the website and based on the shock that you choose. You can get smaller ones, you can get longer ones with different amounts of throw and different amount of weight ratings.